So in this section, we're going to look at finding solutions in an interval for a trig equation where the angle actually has some number times the angle. So for instance, solve in the interval 0 to 2 pi. Okay, so the first example I have here is the tangent of 2x plus root 3 equals 0. So the first thing we are going to do is, like we did before, we're going to say that this 2x here is our theta. So we're going to let theta be equal to 2x. And so now what we are doing is we are solving for the equation the tangent of theta plus root 3 equals 0. In these problems, because we have an interval, so our x was between 0 and 2 pi, right? So that's what that interval there is saying. It's saying solve this equation, but x is between 0 and 2 pi. And so I want to figure out where do I have to look for my answers for theta. And so in this case, if x is between 0 and 2 pi, if I multiplied everything by 2, so now that's saying that 0 is less than or equal to 2x, which is less than 4 pi. Remember, 2x is theta, so 0 is less than or equal to theta, which is less than 4 pi. So 4 pi means I'm going to go around the unit circle twice. So go around unit circle twice. And let me add in this unit circle picture here. We can, oops. I'll put it, actually I'll move it down here so that we can see it. Okay. So going back to our equation, so we're going to solve for the tangent. So the tangent of theta is equal to minus square root of 3. And so I want to find the places where the tangent of theta is equal to minus square root of 3. And those two places happen to be at 2 pi over 3 and 5 pi over 3. So at these two places here, the tangent is equal to minus square root of 3. So two of the answers for sure are 2 pi over 3, and the second one is 5 pi over 3. But there's two more answers I need, because remember, we have to go around the circle twice. So that's just going around on my first go around, right? First time I stop here, then we kept going and we stopped here. Now on the second go around, we're basically going to go and stop here, and then we're going to go again and stop here. So the second go around, basically I'm stopping at the exact same place, but I've essentially gone around the circle once. So I go all the way around once and then I stop. So the second places here are going to be 2 pi over 3 plus 2 pi and 5 pi over 3 plus 2 pi. Now, I have to make those look nicer. So those are going to be, to make them into one fraction. So think of this over 1 over 1. And I'm going to multiply top and bottom here by 3 to make a common denominator. So in this case, we end up with 2 pi over 3 plus 6 pi over 3 and 5 pi over 3 plus 6 pi over 3. So we end up with 8 pi over 3 and 11 pi over 3. 11 pi over 3. Okay, so what does that mean? Well, that means that right now we found that the answers are theta equals 2 pi over 3, 5 pi over 3, 8 pi over 3, and 11 pi over 3. But remember, I'm looking for x, and so we know that 2x, which is the same as theta, is going to be 2 pi over 3, 5 pi over 3, 8 pi over 3, and 11 pi over 3. And so what I want to do is I want to divide all of these by 2 to get my final answer. So x, the final answer is going to end up being, if I take 2 pi over 3 divided by 2, I get pi over 3. If I take 5 pi over 3 divided by 2, I get 5 pi over 6. If I take 8 pi over 3 divided by 2, I get 4 pi over 3. And if I take 11 pi over 3 divided by 2, I get 11 pi over 6. So I just divided out each of those fractions. So let's try another one. So b here, 2 sine of x over 2 minus square root of 2 equals 0. So again, the first thing I'm going to do is I am going to let this x over 2 be equal to my theta. So we're going to let theta be equal to x over 2. Again, remember from the original instructions that x is between 0 and 2 pi. So for our theta, that means 0 divided by 2, all of these. So 0 is less than or equal to x over 2 is less than pi, or 0 is less than or equal to theta less than pi. So if I go back to my original equation, I have 2 sine theta minus root 2 equals 0. And so now I have 2 sine theta equals root 2. Divide both things by 2. So the sine of theta is equal to root 2 over 2. And so now what this is saying is I only have to look between 0 and pi for my thetas. So if I look between 0 and pi for my theta, I end up with theta being equal to, so root 2 over 2 would be pi over 4. And also it would be 3 pi over 4. So both of those are in the area from 0 to pi. And I don't have to look for anything else. And so now I just have to go back to x's. So remember, theta is the same as x over 2. So x over 2 is equal to pi over 4, comma 3 pi over 4. And I want to solve for x. So multiply everything by 2. So x ends up being pi over 2, comma 3 pi over 2, because the 4 and the 2 would cancel each other out. So when you have an angle that's not just x, you can let it be equal to theta. If it's on an interval, you have to do a little bit more work than the ones we did in the other topic, which were not on an interval.